In this video, we're going to start with a problem, and then we're going to model that problem with a linear system, so two linear equations. And then we're going to solve that linear system graphically to answer the problem. Okay, so here's the story. 1 week this summer, I worked 21 hours tutoring and mowing lawns. I charged $20 an hour for tutoring and $15 an hour for lawn mowing. I made $345 that week. How many hours of each did I do? So this is an example of a type of problem that we can solve with a linear system. We can get two different equations going, and then we can graph them, actually on this conveniently prepared graph, and then when the way the lines cross, that will be the answer to our problem. So if we're going to have a linear system, first of all we need to come up with what some variables represent. So if you think about it for a minute, maybe even pause the video and think about what you would have the variables represent. A common sort of wrong answer, and it's wrong just because it's not helpful, it doesn't get you anywhere, is to say that X would be how much you charge for tutoring and Y will be how much you charge for lawn mowing. And the reason this isn't useful is that we already know both of those numbers. We know that it's $20 an hour for tutoring and $15 an hour for lawn mowing. But the answer is actually pretty close to that. One of the variables is going to be, it's usually what the question's asking. One of the variables is going to be the number of hours that I tutored, and the other variable would be the number of hours that I mowed lawns. Okay? And here's how I want you to write it. Make sure you write it like this. It's a little bit formal, I guess, but I think it's really clear, and I think it helps you do the problem better if you define your variables properly. So instead of saying X equals tutoring, if you write that, then it's harder to know what to do next. We're going to write let X represent. So those are just two little words there, but they're important, and I want you to write them every time. Let X represent, and then this part here is important, the number of hours I tutored. If you don't put that in, sometimes you'll be more confused in the next step. And let Y represent the number of hours I mowed lawns. Okay, so this axis down here is going to be my tutoring hours, and then this axis here is my lawn mowing hours. Normally you wouldn't have that already made until you know what the numbers look like, but I didn't think you'd want to sit and watch me do some division and see how many squares I had on my page, so I had that all done. Okay, and then there's two different things we know about my work. The first is how many hours I worked altogether. So I worked 21 hours that week. Now, the two things I'm doing working are tutoring and mowing lawns. So if X is how many hours I tutored and Y is how many hours I mowed lawns, then we have X plus Y. That's the total number of hours I worked. So that'll be equation 1. Okay, the other equation is a little bit more complicated, not terribly, and it has to do with how much money I made. So I made $20 an hour for tutoring and $15 an hour for mowing lawns. If these equations aren't like obvious or pretty obvious to you, then you should pause the video and just do an example. Make up a number of hours you worked, maybe 10 hours tutoring and 12 hours mowing lawns or whatever. Just make up any number and think, how would I calculate the total amount of money I made? So you can pause and do that now if you want. So what I would do, the total amount of money I make is going to be equal to 345. And the way I would calculate how much money I made is I'd take how many hours I tutored. If that was 12, it would be 12, and I'd multiply by $20 an hour, so it would be 12 times 20. Now it's not 12, but it is something, it's X. So how much money I made tutoring is going to be let me just pause and put that away. Okay, so I worked $20 an hour tutoring, and I tutored for X hours. So the amount of money I made is going to be 20 times X. And then the amount of money I made mowing lawns is going to be $15 an hour, so 15 times however many hours I worked. And in your example, you'd multiply the numbers, but here I have 15 times y. And then to get the total, I'd add those two things up. Okay, so here's my linear system. This would be equation 2. So I'm going to graph this linear system, and I'm going to use the intercept method because I think it's the easiest for these equations. So first of all, in blue, here's an example of why it's really easy sometimes. If I substitute x equals 0, I'm not even going to write this down. You can if you want to. But I'll have 0 plus y equals 21. So that means that y equals 21. If I substituted y equals 0, I just have x equals 21. So that means this is 22. I have a point there and a point right there. Join those. Oh, you might notice I've only graphed the positive, the first quadrant here where all the numbers are positive, because I'm not going to be working negative hours. That wouldn't make sense. Okay, and now I'll do the same thing with my second equation, but this one's I'm gonna actually have to write some stuff down. So if I have a little xy table, if x is 0, then we have 20 times 0 plus 15y equals 345. And so 20 times 0 is 0, so 15y equals 345. If I punch that in my calculator, I've got 345 divided by 15 is 23. Okay, and if y were 0, then I'd have 20x plus 15 times 0 equals 345. 15 times 0 is 0. So I have 20x equals 345. I'll divide both sides by 20. So I have 345 divided by 20, and it's 17.25. Okay, so these 2 points, x is 0, y is 23, and x is 17.25, so 17 would be right about there. So this is my intersection point. Okay, now here's hoping I made my graph nice and carefully and that I can guess pretty accurately what those coordinates are. We won't know for sure until we check, so I'll have to do a check for sure on this. But this looks to me like the point 6. And that's 14. This looks halfway between 14 and 16 to me. So 615. And then I'll check here. So I'm going to do, actually maybe in this case it would actually be easier to go, instead of checking in the equations with the left side and right side like I did last time, I'm going to look back at the situation and see if this makes sense, if these are true. So if it's 6 hours, so that would be how many hours I tutored, and 15 would be the number of hours I mowed lawns. So the total hours would be 6 plus 15, and that's 21, and that's what it's supposed to be. So that's good. And then for total pay, for tutoring it's $20 an hour, and it would be 6 hours. And then for mowing lawns it's $15 an hour for 15 hours. let's check what that is. 20 times 6 plus 15 times 15 is 345. That's perfect. Because that's what it was here. Okay, so it checks out. You can see again the problem with graphing is that who knows, maybe that wasn't like, well, I mean, we know it is because we've checked, but if it wasn't for that, it's possible that this could have been the point, like 5.75, 15.2. You know, it's not really clear from the graph, so that's why the check is really important. Okay, good luck.